Hello student, I am Mr. Praveen Kote. Today in third lecture of 11th Science Physics chapter number 8 Sound, we are going to study the factors affecting speed of sound. Okay, now as we start, we know when the sound will travel through the atmosphere or from the open air. There are some factors related to the air which affect the speed of sound. Now we are going to study today we are going to study all these factors. Okay, now in first we are going to study the effect of pressure on velocity of sound. For that we have to consider the previously studied equation, that is the Laplace formula for velocity of sound. It can be given by V is equal to gamma p divided by rho. Gamma is the ratio of specific heats, p is pressure and rho is the density. If capital M is mass of air and V is volume, then density of the air is given by rho is equal to mass upon volume. Using this equation in this equation as value of rho, we get V is equal to gamma PV upon M. Okay, here according to Boyle's law, at constant temperature PV is equal to constant. PV is equal to constant. If PV is equal to constant and M is constant, gamma is also constant, M and gamma is also constant, then this V is equal to constant. Okay, that means at constant temperature change in pressure has no effect on the velocity of sound. Velocity of sound does not affected by the pressure at constant temperature. Okay, this is for air. Now similarly we think this for the ideal gaseous medium. Okay, we have ideal gas equation, that is for gaseous medium. This equation can be given by N R T. Okay, N being the number of moles and V is equal to gamma N R T upon capital M. Okay, for N number of moles this expression can be given by. Again similarly in previous point for air, here is also gamma nRT is equal to constant, M is equal to constant. Hence for gaseous medium which obeys the ideal gas equation, PV is equal to RT, no effect on velocity on the of the sound if there is change in pressure at constant temperature. Okay, this finishes the point effect of pressure on velocity of the sound. Now in second point, if we study, we are going to study the effect of temperature on the speed of sound. For that we have to consider two temperatures T0 and T. Okay, at T0 temperature, V0 is velocity and rho 0 is the density of the gas. Again at T temperature, V is velocity and rho is the density. At the temperature, if you want to write the equations for the velocity of sound, we can write v0 is equal to gamma r t0 divided by m. This is first equation. Now at temperature T, velocity of sound can be given by gamma r t divided by m. This is second equation. Now dividing equation 2 by 1, what we get? v upon v0 is equal to gamma rt divided by m, gamma r t0. Okay, solving this equation we get rt upon r t0, that means under root t upon t0. This is ratio of v upon v0. What it gives? It shows that speed of sound in air is directly proportional to the square root of the absolute temperature. Thus, that means velocity of sound increases with increase in temperature. Okay, v upon v0 is equal to t upon t0. Velocity of sound increases with increase in temperature, as this velocity is directly proportional to square root of the temperature. Now we have to taking T0 is equal to 273 Kelvin temperature. Okay, and T is equal to, absolutely this T is greater than T0. T0 is the initial temperature. Now 273 plus small t Kelvin is the temperature T. Okay, T is the temperature. This T is temperature in degree Celsius at given time. Okay, now the ratio of T0 degree Celsius to given by कसं दिलं जाईल? हे दोन टेम्परेचर झाले. आता आपल्याला काय करायचं? वी हॅव टू फाइंड आउट द रेशो ऑफ वेलोसिटी. कोणतं? दिस इज इक्वेशन. इन दिस इक्वेशन वी कॅन पुट दिस टू व्हॅल्यू, v upon v0. What we get? We get 273 plus t divided by 273. Now this is equal to 1 plus t upon 273. Okay, now solving this equation again, this v upon v0 we get under 1 plus alpha t. What is alpha? This alpha is 1 upon 273. Okay, taking exponential we get v is equal to v0 1 plus alpha t, as it here is square root, its power is 1/2. Okay, alpha is very small. If this value of alpha is very small, we can write equation for velocity v is equal to v0 1 plus 1/2 alpha t. Okay, but we know the value of alpha. What is that? v0 is equal to 1 plus 1/2 1 upon 273 t. Multiply these two. 2 into 273. What we get? 1 plus T upon 546. This 546. 1 minute. 546. Okay, this is the equation. Okay, now multiply this V0. Multiply this V0 into bracket. We get what we get? V is equal to V0 plus V0 upon 273 into temperature. But we have equation value of V0 is 332 meter per second at 0 degree Celsius. ही व्हॅल्यू टाकल्यावर काय मिळेल आपल्याला? V इज इक्वल टू V0 प्लस 332 divided by 546 into T. That means V is equal to V0 plus 0.61 into T. What this equation indicates? This equation indicates that for 1 degree rise in temperature, velocity increase by 0.61 meter per second. Hence, small variation in temperature changes the velocity of sound linearly with temperature. This is the variation of velocity of sound with temperature. By seeing this equation, we get the how this velocity varies with temperature. Okay, now for temperature variation, we have to study two important equation. This is first equation is V upon V0 under root T upon T0, which directly shows that this velocity depends on the temperature and is directly proportional to square root of temperature. If there is variation in velocity, there is change in, if there is change in temperature, there is change in velocity of sound. Okay, this can be directly given by this equation and also this second equation. This is all for the effect of temperature on the velocity of sound. Okay, now we are going to see third factor, that is the effect of humidity on the speed of sound. What is humidity? What is moisture? Humidity in air is nothing but the presence of water vapors. Okay, is the humidity or the moisture in the air. Okay, let density of the moist air and this is the rho d is the density of dry air. Now Vm is the velocity in moist air and Vd is the velocity in the dry air. Okay, by using these two terms we can write the speed of sound in moist air is equal to Vm is equal to gamma p divided by rho m. Rho is density of the, this is equation number 1. Dry air, velocity in dry air is given by gamma p divided by rho d. This is equation number 2. Okay, now divide equation 1 by 2. Vm by Vt. What we get? Now we get the equation rho d divided by rho m. Moist air is always less dense than the dry air. Density of the moist air is less than the dry air. That means rho m is less than rho d. Density of moist air is less than density of dry air. Okay. Density of this is 0.81 kg per meter cube and density of dry air is 1.29 kg per meter cube. Okay. Now as we say that this density of moist air is less than density of the dry air, what about velocity? From that equation what we can say is that we say that as the density of moist air is less than dry air, velocity in moist air is greater than the velocity in the dry air. Okay. Speed of sound in moist air is greater than the speed of sound in dry air. Okay. This is the effect of humidity on the speed of sound. Okay. In today's lecture we have to study 3 factors which affecting the speed of sound when it travels through atmosphere. That is the effect of pressure, effect of temperature and effect of humidity on the velocity of sound. Okay. Thank you.